Okay, the next topic is empirical copulas. And empirical copulas are like trying to fit something close to the data instead of using one of the theoretical copulas. In probability distribution, we did that. When instead of using one of the theoretical probability distributions like binomial or Poisson, we come up with a frequency distribution and use that frequency distribution as our probability distribution. So similarly, in copulas, we instead of using one of the theoretical copulas, um, we come up with something which is close to the actual data and try to use that. So here we're going to look at an example with just two variables, and we'll fit probability distribution for each of the two variables, and then we'll develop an empirical copula between the two variables and use that for the purpose of simulation. Okay, so we're going to set up a scatter plot, right? Now it's using variable 2 on the y-axis. Your textbook uses variable 2 on the x-axis. So let's change that. So we'll put that here, and that on the x-axis. Alright, so now we have the plot, and we can move this down below by format axis. Alright, we have okay, so we can change this to 1 maximum, so that seems to be the maximum value. So maximum axis value, no, this will be automatic here, and okay, label position, put to low, so that goes to here, and that's not variable 2, so let's delete that, and put axis, not axis title, chart title, let's say, oh, x equal to variable 2, y equal to variable 1. Okay, so you see, look at that. So there is a very high variability with x variable 2 equal to 1. So the relationship between the two is not normal. It's kind of unusual. All right. So now what we want to do is to set up say variable 1 and variable 2. Let's set up a probability distribution. Okay, highlight that. Okay, and then go to fit. Okay, so we have a fit, well, distributions. Let's accept the defaults, and then we have Laplace, right to Excel. So that will go into that cell. Okay. So now do the same with variable 2. Okay, so that's a PERT distribution. Okay. I think your textbook uses triangle. So click OK. Next is that. Okay. Now we can run copula. Okay, so correlation define, not define, correlation fit copula. Okay. Okay, click OK for ties. So here is the fit of copula, Clayton R. Alright, so let's write to Excel, and we will write it down here and attach it. Okay, so make sure that you attach it to these two. So this will be a defined copula. Okay, so this will be Clayton. Alright, so we'll close that. Alright. Now we use the same thing, except that we remove the copula part from there. Right? We're going to fit another copula. So this will be, say, we call it V1 empirical, and then V2 empirical. Okay, same probability distribution. Now we're going to apply empirical copula. So we go fit. Correlation. So we go to correlation, define copula, okay, then specify input, which will be these two. Alright, click OK. So now you select from here empirical. So select the Excel range containing the source data, which is this. Alright. So now we have the data set up, and then click OK. Okay, it's asking us where to put the copula. So we say, alright, let's put it there. So now we have empirical copula, okay, and then the data is here, and this is being inserted with copula 2. Okay, so now we can run the simulation. Okay, we'll say automatic 10,000, right? Let's see, sampling is set to fixed 1 and run. Okay, so now let's compare the scatter plot between these two. Okay, let's close this and we go to scatter plot. Okay, now okay, y results are variable 1, x results variable 2. Okay, now this is Clayton Copula. Okay, so the copy graph and paste it here. So this is the scatter plot of variables 1 and 2 simulated using Clayton Copula, right? So now let's close that and go back. Scatter plot. Okay, now this time we will look at variable 1 empirical as y, at variable 2 empirical for x. Okay, so now let's copy the graph and paste it here. Close that. Let's compare the two. So this is empirical copula. All right. So as you can see, this one resembles our actual data much closely than that one. So that one is kind of spread out, whereas here you see it's more scrunched towards this side. Okay.